Hello, boys and girls. This is Miss Moreno. Welcome to Eureka Math, Module 2, Lesson 2. Let's look at the title because the title always tells us what we will be doing in our lessons. Today, we will be interpreting division of whole numbers by a fraction using visual models. So don't get that confused with yesterday. Yesterday, we divided fraction by whole number, but today we are dividing a whole number by a fraction. And let's look at the learning targets. I will use fraction bars, number lines, and area models to show the quotient of whole numbers and fractions. I will show the connection between those models and the multiplication of fractions. And I understand the difference between a whole number being divided by a fraction and a fraction being divided by a whole number. So again, in today's lesson, we're focusing on the whole number being divided by a fraction. So let's take a look at the opening exercise. For question number, I want you to write in. Well, this is question number 1 from the graph that's below. How many half miles are in 12 miles? So here we need to determine, am I dividing a half by 12 or 12 by a half? Remember, the title for today's lesson said you will be dividing whole numbers by fractions. And if I want to know how many halves are there in 12, right, I am dividing 12 by a half. Now, I need to write this as a multiplication expression. So that would be 12 times 2. I'm going to tell you and then I'll show you. Why is that 12 times 2? All right, if I'm doing 12 divided by 1/2, I'm splitting that 12 up into halves. I'm doubling it, so it's 12 times 2. Let me also show you. That will make more sense. I'm going to draw 12 equal units, right? 12 holes. 1, 2, 3, 4, 5. And I'm going to keep going until I have 12 equal parts. So I'm going to do 12 divided by 1/2. So I'm going to split them all in half, right? Because I'm dividing by a half. Notice every time I'm dividing, I'm doubling. Okay, now I'm going to count all my parts. 1, 2, 3, 4, 5, 6. I'm going to keep going, and we have 24 equal parts. So I know that 12 divided by 1/2 equals 24. I just showed you because we had 24 equal parts. And 12, and I write that as a multiplication, 12 times 2, because again, here each unit I doubled it, right? When I split it in half, because I divided by a half, I doubled it and I multiplied by 2. So 12 times 2 equals 24. So right here on this problem, number 1, that's the same one we just did. The purpose of this portion is for you to see the relationship between division and multiplication. We already know how many half miles are in 12 miles. That we write that as 12 divided by 1/2. And I already showed you that the multiplication expression is written as 12 times 2. Because again, I want to know how many halves are in 12. So I'm doubling. I'm splitting up each whole into 2 parts, and I'm counting each half. And to write an equation showing the equivalence of the 2 expressions, all I'm doing is 12 divided by 1/2 equals 12 times 2. So let's look at the next one. How many quarter hours are in 5 hours? So I'm doing 5 divided by a quarter, and we write a quarter as 1/4. Now, if I'm dividing 5 into fourths, I want to count how many fourths are there, right? I'm cutting it into 4 equal parts. So as a multiplication expression, I would write that as 5 times 4. And to show the equivalence of the 2 expressions, I have 5 divided by 1/4 equals 5 times 4. And the last one that I'm going to do with you, how many 1/3 cups are in 9 cups? I already know I'm dividing 9 by 3, 1/3, 9 divided by 1/3, And again, I'm splitting it up into thirds, and I want to know how many 1/3 there are, and I cut it into thirds. So I'm going to do 9 times 3. And the two equivalent expressions are 9 divided by 1/3 and 9 times 3. So go ahead and pause the video, do the next two, and when you are ready, and pause. Example 2. Molly has 9 cups of flour. If this is 3/4 of the number she needs to make bread, how many cups does she need? So this specific problem is telling us to use a tape diagram. If you recall the learning target, it said we would use visual models. So we're going to do one here. So it says construct the tape diagram for part A by reading it backwards. Draw a tape diagram and label the unknown. Here's my tape diagram. And that's the unknown, right? We don't know the value of it yet. Part B, next shade in 3/4. In order for me to shade in 3/4, I need to partition my tape diagram into 4 equal parts. Now I can shade in 3/4. Letter C, label the shaded region to show that 9 is equal to 3/4 of the total. So I'm showing that 3/4 is equal to 9. So the shaded region has a value of 9. I'm going to take the information I have here to solve this problem. So I have, and then I need to analyze. So I have 1, 2, 3 equal parts. If I did 9 divided by 3, I get 3. That means the value of each unit is 3, because the value of 1 is the value of all. And you can check because they add up to 9. Now I have enough information for the non-shaded unit, which is 3. And I can determine that 3 times 4 is 12. So the answer is 12. So I can determine that Molly needs 12 cups of flour to make bread. Okay, let's look at exercise number 1. A construction company is setting up signs on 2 miles of the road. If the company places a sign every quarter mile, 1/4 mile, quarter mile, how many signs will they use? Okay, I'm going to show you using the same model, using the tape diagram. I know the learning target says area model and number line, but right now I'm going to continue with the same model, and when we are working live, I'll show you the other ways. That way you can use the way that you prefer. So we start by doing a tape diagram, labeling the unknown, and I'm going to partition this tape diagram in 2/4 and shade in 1 out of 4 to show 1/4. I know that the shaded region equals 2. And because it's only 1 unit, it makes it a little easier, right? The value of 1 unit is the value of all units. They all have the same value. So now I have enough information to tell you how many signs it will use. Because 2 times 4 is 8, and the company will use 8 signs. Okay, number 2. George bought 4 submarine sandwiches for a birthday party. If each person will eat 2/3 of a sandwich, how many people can George feed? Again, I'm continuing the tape diagram so that you're seeing the same, it's consistent, and in the live video we will do the other visuals. So again, I want to figure out how many people George can feed. I'm going to draw my tape diagram and label the unknown. Each person will eat 2/3 of a sandwich, so I'm going to partition my diagram into thirds and shade in 2. 1, 2, 2/3, 2 out of 3. I know that the shaded region equals 4. And so if I divide 4 by 2, because there are 2 units, I get 2. And the value of 1 unit is the value of all. So now I have enough information to say that the tape diagram, how many people can George feed, that the tape diagram equals 6. So George can feed 6 people. I'm going to go ahead and stop here. I want you to try number 3 and 4 on your own and be ready to discuss them in the classroom. And at the same time, when we're live, I will show you the other ways. Okay, thank you.